Hello students, this is Professor Arul Nitesh and I am the professor for your subject rigging in Maya. I wish to welcome you all to the subject, which is going to be very much interesting and also challenging, and I hope that all of you have already gone through hands-on experience with Maya. I hope you have done your 3D modeling in Maya. You have done your 3D animation in Maya. So it won't be a tough task for you to understand or use the options and menus and controls in Maya. And today in our first class of rigging, we are going to get introduced into some very important and repeated concepts which you will be going through all the way till the end of this course, rigging. So initially we will get some knowledge and clarification in those concepts, so that when we are applying those concepts in real time, in practical models, in rigging in practical models, it will be easy for us to understand. So initially, first we will see what is rigging. Rigging is the process of taking a static mesh. Say for example, if there is a human model, 3D model, okay, which is not rigged, which is only a static model. So in this case, if we consider that human model as a static mesh, we can take that static mesh and we can create internal digital skeleton using Maya. Then we can create the relationship between that static mesh and the skeleton using the technique called skinning, and after that adding set of controls to that static mesh based on the digital skeletons, so that the animator can use those controls to set key poses for animating that human character. Now the static mesh or the simple human 3D model has been converted into a working model because of the process of rigging. I hope you can understand. It is a very static model with no controls. Then we are creating digital skeletons. We are using few techniques so that the model is eligible to be animated by an animator. Okay, this not only applicable for human models or animal models. Okay, there are two important categories in rigging. The two important categories of rigging are organic rigging and inorganic rigging. Organic rigging refers to rigging the models which are from the reference of living beings. Say for example, we can take a dog or a human or a bird or any creature, anything. Okay, that is called organic rigging. And when it comes to inorganic rigging, it involves mostly of mechanical objects such as machineries, equipments, mechanical devices, vehicles, and etc. Let us see the fundamental concepts of rigging in Maya. There are few concepts which are applicable to all the major rigging needs. It is like the first thing is parent-child concept, the second one is constraints, third one is joints and bones, fourth one is rotation axis and gimbal, fifth one is forward kinematics and inverse kinematics, sixth one is the animation controllers, seventh is the skinning. Let us see the first concept, parent-child concept. In parent-child concept, if there are two objects in the Maya workspace, we can make one object as the parent to the other object by giving some connectivity so that the child object can follow or copy the translation and rotation and scaling properties of the parent object. To see it clearly, let us get into Maya where we can see with proper examples. Once when you open Maya window, when you are up to rigging, please check whether your caps lock is off. You can see a small icon on the screen, small notification in the screen, which indicates the caps lock. Okay, caps lock is on. Okay, kindly turn off the caps. Right now, in here, first change the modeling tab into rigging tab. I'm using Maya 2019. Change the modeling tab into rigging tab. Right, then I'm just coming back. Now I'm just going to demonstrate how the parent-child concept works. Students, see all these 7 concepts in the first class itself. For you it may look very strange, but all these concepts, all these techniques are which you are going to repeatedly come across in your rigging course, right? If you are rigging for an human being character, there is going to be joints and bones, and it is going to be rotated, and it is going to have animation controllers, and some constraints will be there, skinning will be there. Okay, so kindly get used to this, right? Take time, understand, keep practice. Okay, I just wanted to repeat the importance of these concepts. Now I'm going back to the first concept, parent-child concept. So this is the Maya workspace. Here I'm going to take two objects or two models, right? The first one, I'm taking a sphere. This sphere I'm going to give proper name as parent, and this cube I'm going to give name as child. So both of them are present in this workspace. So how to give connectivity, how to make relationship between these two objects, that is the parent and the child, right? So before giving any connectivity in rigging, okay, whenever you are bringing in an object, you can see here, right, I have moved this object from the ground level. Okay, so if I make it 0, this is the object's original global value. Global value is where the object is present in the Maya workspace, and where all the values are 0, that is the global value of that particular object. So I want to bring it to the ground level, and I can see the changes in y-axis. Okay, so if I make it 0, it will go down again. So in rigging, before giving any connections or inputs or connectivity, what we need to do is we need to reset all the values, all the transform, rotate values to 0, so that it will be very clear and easy for us to identify the global position of any object. So for that, what we need to do, I'm selecting this object, I'm going to modify menu. In modify menu, I'm just going to give freeze transformations. Okay, before that, open the option box. Okay, open the option box, reset the settings, give freeze transform. Okay, see, previously it was half under the ground, and now it is above the ground level, but the y value was something changed. But now when we have given freeze transform, the y value become 0. So this is the new global value of this particular object. Similarly, for the child object, again we moved it, we translated it somewhere from its original place. So its y value and z value both are changed. So before giving any input, we need to reset the global value, right? So for that, what am I doing again? Go to modify, give freeze transformation. Right. So the global value of both the parent and child is 0. Okay. In this concept of parent-child, when the relationship is being applied, the child inherits the parent. Okay, the child obeys the parent, right? Here the parent is the control holder. Okay, so how to give the connection? So first select the child, shift select the parent and press P. Simply press P. Okay, you can see in the status bar result child, right? Now if I select the parent, you can see both the parent and child both are getting selected together. See, in this case I can move the child. It can be active, independent, but when I touch and move the parent, the child will also follow. Okay, but keep in mind, see, the child can move separately, act separately, but whenever the parent takes control, it should follow the parent. But you can notice something. The child is not completely following the parent. Okay, it is like it has some internal values. Okay, it can translate somewhere, it can rotate into somehow. Okay, from that position it can still be obedient or respondent to the parent object. Okay, and I'm making all the values of the child 0. Okay, I'm giving this name child 1. I'm creating another object. I'm giving the name as child 2, and I want to reposition it to the ground level or to my comfort level. And I'm selecting the child 2, going back to modify and giving freeze transformation. Okay, now a parent can have multiple number of child objects. Okay, one parent, 2 child, or 3, 4, 5, 6, infinite number of child objects. Okay, see, I'm selecting the child again here, shift select the parent, hit P. Okay, so what happens if I select the parent? Both the child objects are moving together, but both the child objects can move separately. But when it comes to the command of the parent, both the objects should respond. Okay, similarly I am going to create another object. Okay, this is, I am going to name it as grandchild 1. I'm going to reposition it. Now the values are changed, so I'm going to modify and freeze transform. The values are 0, and now I want this object to be the child of this object. Okay, so parent, child and grandchild. Okay, but this parent is not directly a parent of this object. Okay, let us see how it works. So I'm going to select this child object, shift select this parent object and press P. Okay, so if I select this parent, this child is following, and if I select this parent, you can see this parent is controlling this child, and this child is now a parent of this child. Okay, so this is the chain, parent of the child and parent of the child, but this and this are not related directly. You can see very well. Okay, even I can show you something like I'm going to animate this child. Okay, I'm going to give set key in the first frame. You can see, right? You can see in my timeline, I'm going to animate this child in the first frame. In the 10th frame, I'm going to bring it to the top. Make sure that your auto key is on, auto keyframe toggle is on. Okay, so I'm bringing it to the top, and again in 20th frame I'm making the Y value 0 so that it is coming to the ground again. So how it will work? It will work like this. Okay, now what will happen if I animate this parent? Let us see. So I am taking this parent, I am giving set key in the first frame, in the 10th frame, or I am going directly to the 20th frame. Okay, in the 20th frame I am moving it somewhere here. Okay, let us see what happens. So this child is still being animated but within its boundaries, but when it is controlled by a parent's movement, okay, it breaks its boundaries, because what is the boundary? It is a set key, it is the limit, it is the XYZ position. Okay, so in 10th frame, what is the XYZ position? See, let me select this parent and let me delete the key, last key. Okay, so what is the actual position given to this child in 10th frame in y-axis? That is some value. Okay, 3.02. okay, whenever the set key is given, it should be there, it should possess the same value. But what happens if the parent takes control? Okay, so in 20th frame, if I am giving set key and moving it, moving the parent, you can see the child breaks its actual given position and takes or follows the values of the parent. Okay, so this is how a parent child concept works. See, a parent can have multiple number of child, first child, second child, and a child object can have its own child. Okay, but how many child objects can be there? That is not going to control the parent. How many child objects are there? Any number of child objects can be controlled by the master parent, I mean the main parent. Okay, so this is one important concept in rigging what we need to understand and we need to practice and go through. And one more thing, so this, say for example, I want to tell one another important point. This is a child of this parent. Okay, a parent can have one child, multiple number of child. Okay, but a child can have only one parent, one direct parent. This child object is a direct child of this object. Okay, indirect child of this object. Okay, but it is having only one actual parent, that is this. This cone is having one parent, that is this cylinder. So let us see one more example. I am going to create some other shape, torus. The same procedure, making it somewhere near to the surface, freeze transformation, and in this now I am going to make this one as the parent. So parent 2, parent of which object? This child. Okay, this child is already connected to this parent. So now I want to detach this connection, disconnect this relationship and give connectivity to this. Okay, so for that what am I doing? I'm just selecting the object, selecting the child, shift select the parent and hit P. Okay, now if I select this object, you can see this object now it is having, this parent is having only one child. Okay, this object is no more a child of this object. So who is the parent of this object? This object. You can see this object is the parent of this object, this child. Okay, and if you simply want to detach the relationship, I mean disconnect the relationship, you don't want to create a new parent for a child, you just simply want to disconnect the relationship. Okay, so I am taking this parent and this child as example. So what it is given here, you can see in the instructions how to detach it, how to attach it is to select the child and shift select the parent object and press P, and it is like select the child and press shift P to separate the child from the parent. So select the child and shift P. Okay, I just did shift P, simply select the child and shift P. Okay, you can see the result in the status bar. You can see the result as grandchild. Okay, something has taken effect, right? So if I select this parent now, it became an independent object. It is no more a parent to this object. Right. This is how we can detach a parent and a child. Okay. So, how to see the connection, how to see the hierarchy technically? Okay. See, for that, again I am doing one thing. I am just going to select this child, shift select the parent and hit P. Okay. So this is the parent and this is the parent of parent child 2 grandchild 1. Okay. How to technically find or identify this hierarchy? This connectivity is, go to Windows. In Windows there is an option called General Editor. In that there is an option called Hypergraph Hierarchy. Windows General Editor, Hypergraph Hierarchy. If you click on this object, this option, you can see the connectivity. You can see the node level connectivity. A node is a representation of each and every object which is present within the Maya. Okay. See, if I select this child, I can select this child, I can select this child. So we can see which object is the child of which object. Okay. So this is a different family and this is a different family. Okay. And this is how we can cross verify which object is being connected to which object. Right. See, this is how the parent and child concept works. This will be we will be carrying this through all the techniques, and I want all of you to watch this again and again till you get clarity, and you can add more number of child and parent connectivity and practice it until your doubts are getting clear. Right. We will see in the next concept. Okay. Okay, I will finish this concept now. The next concept we are going to see is constraints. The next concept is constraints. Constraints are more likely similar to the parent-child concept. In parent-child concept, we can see the child can be somewhere else, but still from there it follows the parent. Okay, whatever the quality or whatever the value given to the parent, okay, that is being inherited by the child. If I want to resize the parent, the child will also scale according to the axis. If I want to resize this, see, the child is also getting affected. Okay, but same kind of concept, but not very open, or it is not like something very directly to follow the parent. Okay, unlike the parent-child concept, the constraints play a very important role in deciding which characteristics of the parent should be inherited by the child. Say, for example, if we connect two objects with the parent constraint, say for example one parent object and one child object, and I am giving parent constraint, the child will take only the qualities from the parent, only the input or the values from the parent, in place of only the translate and rotate. Okay, translate XYZ, rotate XYZ alone will be affected when it is given parent constraint, not the scaling, not the size. Okay, so for that we have separate constraint called scale constraint. Okay, why do we have these many constraints, like parent constraint, which controls or which influences only the translation and rotation of the child or the connected object, and the point constraint, which influences only the translation, or it is like only the global translate XYZ values, and orient constraint only for the rotation, and scale constraint only for resizing or the scaling of the object. Why do we have all these kind of different kind of constraints? We will see the need of all these constraints in example with the help of examples in Maya. Okay, first we will see how the parent constraint works. So we are going to see the parent constraint. Okay, I'm just opening Maya. So similarly, like what we did for the parent child concept. Okay, I'm going to change it into rigging tab. I'm just going to take two objects and I'm going to explain it. It is not exactly like parent child concept, so we should mostly avoid the parent child words here, so we can use the terms called constrained object and target object. Okay, so this is the first object which is going to influence the target object. Okay, so this is the target object or constrained object. With this object I'm going to attach this object. Okay, this is object 1, I'm going to attach object 2. So I'm creating two different objects. Okay, so I'm just going to bring it, place it somewhere comfortable, right? So again, what am I going to do is I'm going to give proper naming. Polysphere, I'm going to make it object 1, and this thing I'm going to make object 2. And what we used to do now, that we used to select the objects, go to modify. Before giving any inputs, we need to do this. Select the objects, go to modify and give freeze transformations. Okay, now the global values are set to 0, right? So when it comes to parent child, this is enough. But when we are giving constraints, okay, in advanced level, there may be any form of inputs. Okay, if I modified this cube, that input will be available here. Okay, so all this information are not needed for me, and also this information may affect my rigging. Okay, my rigging setup. So I'm just selecting both of these objects. I'm going to do one more new thing before giving the constraints. I'm going to go to edit and delete by type history. Now if I click this object and come and see here, there is no previous history. Okay, so there is no any unnecessary unwanted information available for this object, right? This thing you will come to understand what is the need of this, and all these things you will come to understand in your upcoming classes when we are implementing this with the help of bones, skins, and etc. Okay, now first we need to understand the basic concepts. All right, so this is going to be the influencing object, and this object too is going to be the influenced object. Okay, so I'm just going to make it rigging, go to constraint. See, in parent child we selected child, then shift select parent, and given simply we pressed P, okay, to make this object as parent. But here when it comes to constraints, first I need to select the parent, I mean the main object one, shift select the child, go to constraint. First I'm going to check parent constraint, okay, which is first option given in our text. Open the option box. See, before giving any option, don't click directly. Okay, open the option box, right? Open the option box, reset the option box. See, you need to check for maintain offset. At sometimes if it is not enabled, you should enable it before giving the connection. Okay, now I'm just giving reset settings. By default it is enabled. Now I'm selecting the object 1, shift select object 2, and I'm just giving apply. Okay, and close. Now if I select this object, you can see this object is moving. Okay, but what happened in parent child concept? When we selected the parent, the child is also been selected. But why it is not happening here in this constraints? It is because it is clearly said here, okay, in parent constraint it is influencing the object only in the terms of translation and rotation, that is movement and rotation. Okay, see here it is, when you select the child you can see the influence of parent in all the attributes. Translation is influenced, okay, you can see the red color, you can see the red color in rotation, in scaling and visibility, everything. So there is no difference between selecting this and this parent and this child. Okay, whatever it is going to do, this is also going to do. Okay, so the influence of this parent in each and every attribute, okay, is forced on this child in parent child concept. Whereas in the constraints, okay, this is the main object, object 1, influencing object. This is the influenced object. If I select the object 2, you can see the influence is being applied only to translate and rotate. Translate XYZ and rotate XYZ. Okay, you can see the scaling is not affected, the visibility is not affected. So that is the reason if I select this object 1 or this parent, this child is not getting highlighted. In here, if you select, both will get selected. You can see the selection. Okay, both are in green color, but here you can see it is partly influenced. So the complete influence is not here. That is why it is not getting selected completely. See, I can rotate it. Okay, I can move it, but if I want to resize this object, you can see the child is not getting affected. The scaling value of this child is same in the 1. The values are 1, but see here the values are changing. Okay, yeah, the values should be 1 by default value. Yes, if I move this translate y, you can see the translate y of the child is also getting influenced, right? So this is how the difference between parenting and constraining is being explained. Okay, why do we need these different constraints? Okay, see, why do we need these different constraints? It is because a human body is having various parts which needs various type of controls. Okay, see, I want to move and rotate my shoulder. It is possible, so there I can use parent constraint. Okay, I can connect the bone and the mesh using the parent constraint, so I can move and rotate the shoulder. It is practically possible for a human being, but I cannot increase the size of a shoulder. Okay, I cannot make my shoulder bigger than what a human being is having, right? So this is not practically applicable. So that is why for different needs of rigging we have different kinds of constraints. Okay, so I hope you understood the parent constraint. So the next thing, let us see, it is similar, right? The next thing we see point constraint. Okay, so here, okay, I have given constraint now, right? You can see the influence here. How am I supposed to break the connection? How am I supposed to remove the connection? Okay, how to see the connection actually? Go to Windows, General Editor, Hypergraph Hierarchy. You can see, okay, object 1 is here, object 2 is here, object 2 is influenced by parent constraint. Okay, object 2 is having the input of parent constraint, you can see. So if I delete it here, what happens? That's all. Both the objects become independent. Okay, now if I select the child, see, there is no influence of the parent. Okay, the blue color highlighting has been gone. Okay, there is another way. Okay, there is another way. I'm just giving Control Z and I just did undo. Okay, I just want to undo. Yeah, I brought back the connection. Where can I see the connectivity again? Yes, now I can see the constraint in outliner. Select the outliner. You can see object 1 and you can see object 2. Click on the option. You can see the chain link. It is called the connectivity. You can see the symbol of a chain link. Okay, so this connectivity is the parent constraint which is being influenced by this object. So I'm going to delete this. Yes, now both the objects are independent. Okay, I want to tell one more important point. I will tell that point using parent constraint itself. I'm selecting, when giving the constraint, select the main object, select the second object, go to constraint. I told to open the option box and check for maintain offset. Okay, what will happen if you did not give maintain offset? Offset is what? Offset is this object is having some global value. This object is having the global value. Okay, the zeros are here in this position and the zeros are here in this position. If I move this object, you can see the global value is changing. The translates x. Okay, so I'm making it back 0. What is the need of maintaining offset is, this is the offset value actually, wherever it is present, wherever it is the object is present in the Maya workspace with all the values are 0, that is called the offset value. Okay, so I want to maintain the offset value. I mean, the parent can be here itself, the child can be here itself. Okay, still they can have connection. So I'm selecting this parent, shift selecting this second object or child, and I am giving apply. Now I can see the connection happen. Okay, but what will, I'm just giving Control Z, but what will happen if I remove maintain offset? Okay, I removed maintain offset. So this is the influencing object parent, and this is the influenced object child. Shift select, give apply. See what happens. The parent is selected. Okay, but the child lost its original offset value. Okay, it now the child do not have any original offset value. What is an offset value? It is the global position in the workspace, okay, which the object is having all the values 0. Now the object has lost its offset value and it is forced to inherit, or it is forced to take the translation values, okay, of the parent. So that is why, so this is not needed, or this will be confusing, or this will make our rig to work improper when we are rigging for characters. So I'm just going to undo it, undo, Control Z, yeah, bring it out. Okay, again give maintain offset, give apply, it is there. Okay, so this is the purpose of maintain offset. Okay, now we will see it is parent constraint concept.